Hi everyone, welcome to the seventh lesson for topic 4.4 Newton's laws of motion. So yeah, it has been the seventh lesson. So we actually spent quite some time in this lesson to discuss about different problems that you will be modeling. Okay, so yeah, let's do a very quick recap on the thing that we have learned so far. So in the first lesson and the second lesson, right, is a time that you are introduced the first time that you are introduced the Newton's second law of motion, which how to use the formula of F equals to ma. Then we look at some simple problems, which is basically one dimension question. Then that's the time that we combine F equals to ma and Suvat formula together. Okay. Then in the third lesson, we are bringing it in a one level higher. So which is we talk about F equals to ma Suvat, but now we have frictional force involved. So which means we are talking about like a car moving on a horizontal plane. Then after that, there's friction involved. Okay. Then after that, for the fourth lesson, it's the same thing. We talk about F equals to ma. We talk about Suvat and we talk about friction. But at this time, all your motion is actually at the slanted plane. So that's why you require resolving forces when you try to deal with all this question. Okay, then after that, in the fifth lesson, we talk about, for the fifth and the sixth lesson is a time that we start to discuss about the Pulley system. Okay, so under pulley system for the fifth lesson, we talk about if let's say you have a smooth pulley, then after that it's connected, at the end it's connected with the two particle which hangs freely in the air. So this is like a vertical pulley system. So in the sixth lesson, we talk about if let's say the pulley system is placed at the edge of the table. Okay, so it's something like this. Then you have a pulley that is on the table, then is connected to the pulley, and the other end you have the other particle. Okay, so for today's lesson, we are still going to discuss about pulley system, but it's in a slanted plane. So the questions that you will be encountered today will be in this case. So it's like this. So you have one particle over here and the other particle over here. So this is the first time, or the first type. Then another type is the type that you will be seeing it quite often for the reason paper. So it's a pulley system. So both of the particle that connected by this pulley system, right, is both on this pulley, is both on this slanted plane. Okay, so I hope that you can see a difference here. So basically for this one, you need to do, when you try to do the vertical one and the horizontal plane one, so there's no resolving forces involved. So what you are trying to dealing with is like how you understand it as a combined system. Then you take into the consideration of tension. Then after that, the net force equals to ma. So stuff like that. But for today's session, we'll be doing everything together, which we involve resolving forces as well. Okay, and one of the special thing that we'll be looking at today is for the part where what to do if let's say we do not know which direction the particles are moving in. Okay, so because this is a problem, so you see, right, when we try to discuss the pulley system in a vertical system, so you can see that these two particles are just hanging freely in the air. So that's why we do not take into the consideration for air resistance, and there's no contact there's no contact of this particle with the surface, right? So that's why you don't have the normal reaction and you do not have the friction. So it's very easy for us to identify which direction the particle will move into. Because if let's say this one is heavier, then it's going to move into this direction. If this is heavier, then it's going to move into the other direction. So it's the same thing as well for this one. So you only have two cases. The first one is either this particle is having a large mass enough so that it creates a weight that is enough for it to overcome the weight for this particle and also the friction, then the pulley system will move. If let's say the force here is not large enough, then which means that it will be in equilibrium, as if the forces that you exert is not enough to overcome the friction, the limiting friction that you have. Okay, so normally, so it's very easy for us to identify that. But for today's question, right, or there will be a possibility that you wouldn't be able to identify whether the particle is moving into this direction or that direction, because when you try to look at the slanted plane, so it's not easy as the vertical system that you want to identify the weight, right? Because your mass, the weight is in this direction, but then the forces that actually take into the consideration of your motion is the comparison of forces in this direction. So that's why we will need to do a lot of resolving for today's question. Then we will try to see, if let's say we do not know which direction, then what do we need to do? Okay. So before that, by this time, I hope that you are very familiar with how do we do the connected particles in combined system. Okay. So if let's say you're still not sure about that, please make sure that you go through the lesson 6, especially I guess. So when we discuss about how to solve the system, no matter by using a combined approach or a separate approach. Okay, so we'll be looking at 3 questions today. So yeah, they are all past year question. So after we did the first question, then we'll come back to this part, because I want you to understand that it's not true to assume that this system will always move in this direction towards the vertical direction here. Okay, so we'll come back to this later. So now let's try to look at example 1. All right, example 1. So this question is considered a easy one. So it's not like easy, a very standard one, I would say. Yeah, so it's not like a very challenging one. Okay, so although it's like 7 marks. Okay, so two particles of masses 5 kg and 10 kg are connected by a light inextensible string that passes over a smooth pulley. Okay, so the 5 kg particle is on a rough fixed slope, which is at an angle of alpha, and the tangent alpha is 3 over 4. So maybe we can write down that. So tangent alpha is 3 over 4. So we know that tangent is OA, right? So by looking at 3, 4, then you should know the hypotenuse is 5 lah. Then after that, we also know that sine alpha is going to be OH. So that's why it's 3 over 5. Okay, then after that we have cos alpha, which is going to be 4 over 5. Okay, so you should be pretty familiar with this already. So the 10 kg particle hangs below the pulley. So the coefficient of friction between the slope and the 5 kg particle is 1 over 2. Okay, so please make sure that when you try to read until here, you do not assume that the friction will always goes in this direction. Okay, so I'll show you why is that so in the introduction later. So we are trying to do this question first, then after that I'll explain it further. So the particle are released from rest, so meaning that the u is 0. So the question wants us to find out the acceleration and the tension in the string. So it's like pretty standard, right, the question. Okay, so now let's try to label all the forces that we have. So 10 kg, so that's why we have 10g here, which is 100. So we have 5g here, which is 50. Okay, so for this particle is on the surface of the plane, right? So that's why we have this normal reaction force. Then also we have, when we try to draw it, so this is our alpha lah. Okay, so the idea is, as long as you can see that the angle beside the alpha here is like a right angle triangle, then definitely you know that these two plus together is going to give you 90. So that's why this is 90. So which means this angle is basically the same with this angle. Okay, then after that we have the tension going up. Okay, so now you see there's one forces that we didn't label yet, which is the friction. Okay, so now this is the time that we need to find it out. So you must remember that friction opposing the motion of the particle. So which means that it will actually act opposite of the side where having the more force. You get what I mean? Because the side that having more forces is going to be the side that the particle move towards, right? So that's the idea of it. Okay, so when we try to look at this question, right, so what do we need to know if we try to view it as a combined system? So we have this side, we have this particle, which is 100 Newton here. Okay, then it's connected with this tension, right? So tension, they eliminate each other. So I have the second particle, which holds it in the other direction by the weight, right? but the weight is not in the direction that we are looking at because the line that we have is basically like this. So that's why we need what is the forces here. So for this force is going to be 50 sine alpha, right? So 50 sine alpha. And sine alpha is actually 3 over 5, so we know that for this side is 30. So it's actually because of you can prove that the forces over this side is actually more than this side, so that's why the whole pulley system is going to move in this direction. So if let's say the motion is towards that direction, so which means your friction will be opposing it, which is in this direction is your friction. Okay, so I hope that you understand the idea. So later we'll be looking at how if the weight here, this is 5 kg and this is 10 kg, then what happened? Is it going to be the same? Okay, so yeah, for this question, I think it's easy to identify because definitely you know that when you sine or cos something, right? I mean, the value of a sine theta, it will be always between 1 and also, oh, sorry, it will be always in between -1 and also 1. Am I right? So that's why when you try to multiply with a number, then it will actually make the number become smaller. So for this one, you already know that you have 100. So if let's say this is 50, it's already smaller than 100. Then if you were to cos or sine something, then definitely it's going to give you a number that's smaller than 50. So obviously these forces will be smaller than 100. So that's why this pulley system is going to move in this direction. Okay, so that's the idea. All right, so when we try to solve this question, I think it's good that we can try to do some recap here. So in case you forget how to solve it in terms of a combined one or a separate one. Okay, so let's try to start with the separate one maybe. So if let's say we were to solve them separately, so which means that we will have these two different things. So the first one is for the 10 kg one. Okay, so it's going to be like 100 going down, then we have this tension going up. So for these forces, then what do we have is we have 50 here. Okay, then after that we have R, and then we have friction. Okay, so that's the idea. So now let's try to, sorry, I forget one more. The same surface, we have the tension. Okay, so now let's try to see if let's say we do it separately. So since there's friction involved, then it will be helpful that for us to find the normal reaction first. So resolve it to this direction. Okay, so we are resolving it along the plane, right? So you should be quite familiar with this already now. Okay, so the normal reaction will basically equal to 50 and then cos alpha. Okay, so from here then I have 50, cos alpha is 4 over 5. So that gives us the normal reaction is 40 Newton. Okay, so then after that, now we continue to solve for this one. Sorry, we can write down first. So remember, yeah, this particle is actually moving, so it's not in equilibrium. So that's why you should use F equals to ma, but not the resulting force is equals to 0. So in this case, we know that the system is going to move in this direction, right? So that's why this will be 100. So let me write down this is for 10 kg. Okay, so we have the 100, then minus off the tension, then it will be equal to the mass, which is 10 kg, and the acceleration. So this is our first equation. Then after that, let's look at the second one for 5 kg. Okay, so we are going to resolve along the slanted plane, right? Because we need to take into the consideration of the t here, so that's why it will be easier for us to do that. So since the direction again is moving towards the other side, so that's why the net force that will be exert is actually the tension minus of the forces to this direction. So we have friction here. Let's try to write down everything first. So we have friction here, then we have the 50. So I think it's easier that we refer to this. So 50 and then sine alpha. Okay, so the normal reaction is basically perpendicular to the surface, so you doesn't need to take into consideration of that. So basically, it's just that Pulley system move into this direction. So net force, it will be the tension, then minus of the friction, and also the 50 sine alpha. So now let's try to substitute all the information that we have. So equal to, I'm sorry, so 5 kg and acceleration. Okay, so now let's substitute. So T minus of the friction, so 1 over 2, the R that we get is 40, so this is mu R. Then minus of 50, sine alpha is 3 over 5, right? Then equal to 5A. Okay, so let's try to simplify a bit here. So we have negative 20 minus of 30, so we have T minus 50 equal to 5A. So this is our second equation. So now just solve them simultaneously. So it's easier to start with A first because we have tension and tension. So first equation plus the second equation, and that gives us that 100 minus of 50. So I have 50, then it will be equal to 10A minus 5A. Sorry, plus them together. So 10A plus 5A, it will be 15A. So from there, I can get A is equal to 10 over 3, so which will be equal to 3.33 meter per second squared. Okay, so that's the idea. Then after that, we can use our second equation to just solve it quickly. 50 minus of 5. Remember to use your full value, yeah? Okay, so our T will be equal to 200 over 3, which can be written as 66.7 inch SF. Oops, sorry, Newton. Okay, so I think this is pretty easy. So just like that, then you get 7 marks already. So the other alternative that you can do is do it as combined system. So which means that the picture that we'll be looking at is combine them together. So we know that this is the particle, right? It's combined by the string and with the pulley in the middle. So we have this particle. So since we know that the tension is going to eliminate each other, so that's why we doesn't need to label that. So we only look at like the external force. So we have on this side we have 100 Newton. Okay, on this side, we have our 50 sine alpha and also the friction, don't forget, okay? It's going to contribute in this side to opposing the 100 here because the motion is moving to this direction. Alright, so the good thing about combined system is that we can always try to solve acceleration first, then after that we use the separate system to help us to solve the tension. Okay, so similarly, I don't repeat this already, so the R is just going to be the same, which the normal reaction is 40 Newton. So when you try to look at it combined in a combined system, so which means the forces that left out, I mean that remain at the combined system will be 100 minus of 50 sine alpha minus of the F, which acts in different direction, right, then equal to, so don't forget the MA that you put should be the M for both. Okay, so let me just write M1 plus M2 and then acceleration. Okay, so by looking at this, so this is basically a equation that you do not have tension, and it's just a simple equation that you have only one variable. So we can straight away solve A. So now let's try to substitute. 100 minus of 50 sine alpha is 3 over 5. Okay, minus mu r 1 over 2. Yeah, it's the same thing like if let's say right 0 0.5. 1 over 2 then 40. Okay, equal to mass 1 plus mass 2 is 10 plus 5, then A. Okay, so when you solve this, then what do you get? So 50 minus, 100 minus 30 minus 20, so it's 50 as well, equal to 15A. So you see you are just getting the exact same answer. Okay, so 3.33 meter per second square. So the equation that you form here is basically the same with the equation that you form when you solve your simultaneous equation together. I mean, in this case, yeah, I mean, if let's say you didn't simplify anything, then when you add these two up, you are just getting the exactly same thing because that's the idea where the tension eliminate each other. So after we get this, then you need to choose either one to solve that. So I guess it will be easier for us to use this because you don't need to do any resolving, right? That's easier. Then after that, after we get A, then we try to look at the particle for 10 kg. Okay, so we know that 100 minus of T is equal to 10A. So now just substitute all the value that we have for the A. Okay, then when you try to solve it, so 100 minus 10 times 3.33, then you are just getting the same answer, which is 66.7 as well. Okay, so that's the idea for a combined system. So I hope that you are familiar with it now. Alright, so this is like alternative lah, so depends on you which you prefer. But you must know how to do combined system, as if later we are going to do some comparison which you do not know which one is heavier, and so then you need to determine which is the direction that your pulley is moving towards. Okay, so now let's try to go back to the introduction part, which I want to give you an idea of. If let's say the here is 5 kg and 10 kg, then what happened? All right. Okay, let's try to look at this picture. So we doesn't need to follow the exact question. So the idea is I want you to maybe check, do you think will there be any movement for this diagram here? Okay, so same thing, let's try to label all the forces here first. And we're going to use the same alpha as the question just now. So which means tangent alpha is 3 over 4. Then sine alpha is 3 over 5. And then the cos alpha is 4 over 5. Okay, so let's label all the force here. So we have 50 Newton. Okay, then after that, this side we have 100 Newton. Then normal reaction. So this is our alpha. Okay, so now by looking at this, tension. Okay, so by looking at this picture, do you have any idea, or do you still think that this system is going to move into this direction? So it's very hard, or it's like too judgmental to say that, because the idea is that you can see that the weight here is 50 and the weight here is 100. So this weight is now bigger than this weight, right? But we know that the force that will actually create the force is the force that along this line. So that's why we still need to get what's the force over here. So when we try to resolve it, then what do we get? We can actually get 100, and then it's sine alpha. So our sine alpha is 3 over 5, so which means this force is 60. So as you can see here, right, this is 60 and this is 50. So where is the particle moving towards? It actually goes to the other side, because this is heavier, am I right? And because of this particle is moving towards that direction, so that's why in this question, our friction is no longer in this direction, but is opposing the motion, which is in this direction. Okay, or I should draw another like better idea is that I should draw like a force that do like this up, but the idea is we normally look at the direction, right? So it's the same thing, so which means this is a friction that opposing the direction of the particle here, so that's why it's moving upwards. Okay, and now let's try to see, do you think that the particle here is going to move? So let's try to understand it in a form of combined system. So you can imagine that this is my particle of 5 kg. This is my particle of 10 kg. So they are connected with this pulley system. Okay, so there's a force which acts by the weight of the 5 kg particle, so which this is 50. So towards the other direction, I have the resolving weight as well for this particle, right? So which is going to be 60. So that's why you can see that the forces over this side is actually more than this side. So if you can recall, right, in Newton's third law of motion, we talk about if let's say you try to exert a certain force, there will be a force that always acts in the opposite direction and is trying to opposing it. So that's why that's what meant by friction, am I right? So that's why it's due by the extra forces that you have in this direction. So that's why what happened here is our friction will be opposing it. So that's why the friction acts in this way. Okay, so now my question is, what do you think that the forces here is large enough for this particle to actually move? So let's try to check on it like this. So you remember when you try to exert a force, then there will be friction. When you try to exert a larger force, the friction will be larger. Then until the end, so okay, which means let me try to just draw one more here. So when you try to put a box, okay, when you apply a certain force, then there will be a force opposing it, right? Then after that, when you try to exert some more force, then the force will eventually become bigger as well. Then after that, when you try to exert some more, then the force will be become more. So you can see the magnitude that will be always the same. But until a time where you apply force is actually become more and more, but the friction here already reaching its limiting friction, then the particle will actually move in this direction. Am I right? So that's the idea. So it's the same thing that we are looking at here. So what do you think is the limiting friction for this particle? So we can always check from the R, right? So the normal reaction here is going to be the 10 kg. So I'm sorry, the normal reaction is going to be 100. Then after that, cos alpha, right? Then it will be equal to 100. Cos alpha is 4 over 5. So that gives us 80. So by using the same mu that we have in the question just now, so we can know that the limiting friction of this question is actually mu r, which is 1 over 2 multiplied with the normal reaction, which is 80, and that is 40 Newton. So that's why the maximum friction that you can exert here is actually 40 Newton. So that's why if let's say you have, let me try to use the other color. So now you have 60 movers to this direction, then 50 movers to that direction. So that's why our net force here is actually 10. Am I right? So that's why in this case, actually the system is not going to move. So for this sign, it's just we talk about if let's say there's no friction. So I hope that you understand what do I mean. So the net force here is 10. So the 10 here is actually lesser than 40, right? So you still can exert some more forces because the maximum friction has not achieved yet. So that's why you can still add it until like 20, then the particle will stay in equilibrium. It's not even limiting equilibrium, you get what I mean? Yeah. Then after that, which means this one, it becomes 70 and you have 20, then the particle still not move because it's not more than 40 yet. Then after that, you add it to 80, then it's 30, it's not moved yet as well. So when it's 90, then it's 40 now. And you see that the forces here is 40, which is, this is the limiting equilibrium already. And if let's say you try to add in some more until 100, so maybe this is 50. So this is a time that your friction cannot add on anymore, right? So the forces that going into this direction will be just 50 plus the 40, which is 90. So now 100 is already more than 90, so that's why the object starts to move. Okay, so I hope that you can see this whole picture. So it's important for you to understand that it's not always it will move into the direction of this vertical one. But of course, in our questions, normally the question didn't will not actually really ask you to identify whether they move or not, or because if let's say the question were to ask you to find the tension and acceleration, then obviously you know that it moves. So which means for this part, then maybe if let's say it's moved towards this direction, then which means this forces is very big, that is enough to overcome the weight here and then the limiting friction here. So that's the idea of it. Okay, so I hope that you can understand better. Let's move on to example 2. Okay, example 2. So this is a question of medium level, I'll say. It's not like a very challenging one. So the idea that I wish to put in more discussion is like the last part, which after B reaches the floor, then what happened to particle A and so. Okay, so there are other much more challenging question in your exercise, which giving you like 8 or 9 marks for one sub question. So I think it's good for you to explore yourself because it's similar like what we have did in a previous lesson. Okay, the one that the last example that we did together, which is like the harder one. Okay, so now there's two particle A and B. So the mass is given attached by the string, so passes through the smooth pulley. Then after that, A is on the plane that incline at the angle theta here. B hangs freely, right? So yeah, this is 0.8 meter above the ground. Then after that, yeah, you can try to read through. So it's pretty long. So let's try to label all the force diagram. So here we have 20m as the weight. So for A, similarly, the weight 30m. So since A is on this plane, so that's why we have the normal reaction. Okay, then let's try to label theta. All right, then tension. Okay, so given that the plane is smooth, find the value of theta for which A remains at rest. So meaning in part A, there's no friction involved yet because the plane is smooth. So if let's say A remains at rest, so you can imagine, right? When B move, then A certainly will need to move because this string is inextensible. So that's why they should be moving in the same velocity or the same acceleration in this form. So by looking at this one, if let's say A remains at rest, so meaning B remains at rest as well. So which means the whole system is actually in equilibrium. Okay, so now depends on you whether you want to solve it separately or you want to solve it as a combined system also can. So let me just try to draw it up here if let's say you want to solve as a combined system. So the forces that we will need is, this is A, this is B, okay, then they are attached by the string, right? Okay, so you can see that, let me try to use the other color. Okay, so the force along the string here is the 20 m here. Then after that, for this side, it will be the resolving. So I'm using the other color because just to show that this is not the extra force, right? This is the force that after I resolve. So this is going to be 30 sine theta. Okay, so this is like the external force, which we have 20 and then 20 m to this side. Then we have 30m sine theta to this side. Okay, I guess this is very straightforward already because the system is in equilibrium. So that's why it's just that left hand side is equal to the right hand side. Okay, so sine theta is 2/3. So that's why theta to 1 decimal place. So it's 41.8. Okay, if you want to solve it separately, it's going to be just the same thing, but just that you have a tension. Okay, so which means for this one, then it's very straightforward. It's just a tension equal to 20 m, right? This is for the B, for particle B. So for particle A, then what we have here is also the tension going up. So the tension will be equal to, oops, I left out the m, 30m. Okay, so same thing here, we have 30m sine theta. So you see, they are on the same string, right? So that's why their tension is the same. So when we try to equate them together, it's just basically the same thing like what we get from the combined system. Okay, so sine theta is 2/3 also, and then theta is 41.8. So both answer can be accepted. So depends on which one you like to use. Okay, so now let's move on to B. It is given instead that the plane is rough now, the theta is 30, the acceleration up the plane is 0.1. So that's why by having this, I'll use orange color for a new question here. So yeah, the theta here is 30 degree. Okay, then the acceleration of A up to the plane is 0.1. So which means that now the whole system is moving to this direction because they say particle A moving up, right? And the acceleration is 0.1. Is that fine? Okay, so now the same thing, if let's say the system is now moving in this direction, so which means the forces here is actually larger than the force there. So your friction should be opposing the larger force, right? I mean, should be opposing the net force. So that's why in this case, your friction will be moving towards this direction, is your F. Okay, so that's the idea. So now let's try to see how do we continue and what do we need to find. So show that the coefficient of friction between A and the plane is 1 over 10 square root 3. Okay, so which means what we need to do here is from the acceleration, then there's no tension involved. So I guess in this question, it's easier for us to straight away solve in terms of the, what is that, in terms of a combined system. Okay, so let's try to write down. This is the new one. So we have theta is 30 and we are given the acceleration is 0.1 meter per second square. Okay, so since there's friction involved, so let's try to solve the normal reaction first. So for this term, we have R will be equal to 30 m, and don't forget this is 30 m, don't write 30 only, so you'll have a problem when you solve later because you should have m all the way, then after that at the end, then the whole equation can be divided by m, and that's how you eliminated m, right? So will be equal to R, then 30 m cos theta. 30 m cos theta. So which is 30. So by using your calculator, then you'll be able to get 15 square root 3 m. Okay, this is like Newton as well lah. Should write like this. Okay, so now we'll be doing the combining system, so that is easier. But if let's say you want to do it separately also can, or it's just that you will be doing simultaneous equation, then you solve them. Okay, but since this question doesn't require us to get the tension, then we are given the acceleration, so it's easier for us to look at it as a combined system. So the net force, sorry, I don't have enough space there. So the net force will be equal to the total mass multiply the A, right? Okay, so what's the net force in this case? So it will be the 20 m minus of the friction and minus of 30 m sine theta. Okay, so 20 m minus of the friction minus of 30 m sine theta. Then it will be equal to, what's the total mass? Yeah, we have 2m and 5m, right? Sorry, 2m and 3m, and that gives us 5m. So the acceleration is given, which is 0.1. So let's substitute the other 20m minus of the mu is what we want to find. Multiply the normal reaction that we get just now is 15 square root 3m. Okay, then after that minus of 30m sine theta is 1. Sine theta just now is how much? Oh yeah, it's sine 30 is 1 over 2, I guess. Okay, then after that equal to 5m multiply 0.1, so that gives us 0.5m. Okay, so now we can actually simplify everything here. So we have 20m minus of 15 square root 3m mu minus of 1 over 2, so that's why it's 15m equal to 0.5m. So you can see you have m all the way. So 15 square root 3m will be equal to moving this in front. So we have 20 minus 5 minus 15, so that gives us 5, then minus of, then you get 4.5. So m no more, then, oh, sorry, where's my mu? Here. Okay, so mu will be equal to 4.5 m divided by 15 square root 3 mu, and that will actually give you square root 3 over 10. Okay, which if you want to write it in the terms of what is given, then it's like this. Alright, so proof. Okay, so that's really the answer for your part B. Okay, so now let's move on to C. When B reaches the floor, it comes to rest. Okay, so another color. Okay, so B, so now the system is moving in this direction. So that's why the B will just continue to move until it reach the end here. Okay, so it comes to rest. Then find the length of the time after B reaches the floor for which A is moving up the plane. Okay, so you may assume that A doesn't reach the pulley yet. So the idea is that you can imagine when B actually moving down until this point, right? A will be moving up as well. Okay, then how much the B move will be exactly the same with how much the A move. So let me try to write like this. Your S for your first stage here is just the same. So the S here, okay, is going to be the same as the S here. Then after that, your V here is going to be the same with your V here as well, because they should be moving in the same acceleration and they are both started at rest. So yeah, let me just U equals to 0. Okay, so the idea is that when B hits the ground, it's because of it's hitting the ground. So that's why it become, the final velocity here wouldn't be 0 as well, right? But it's just that it hits the ground, so it cannot continue. But for A, right, you imagine that when it's here, there's no something that's like a floor or the ground that try to resist the motion. So it's the same thing like when we said the previously, the particle should actually stop when the final velocity is 0. So when the particle is here, right, it actually doesn't stop. The string at once, it will actually become slack in one moment that it will actually become going up, then after that falling down again. You get what I mean? So you can imagine it's the same thing when we talk about the vertical particle. So which we have, if let's say this thing is trying to move, right? So there'll be one situation where this thing is moving longer, so this will be shorter, right? But when it hits the ground, then this is the part where you will have a situation where it's like this. Then this thing is still going to move because the final velocity here is not yet 0. That is still moving, but it's moving with a negative gravitational acceleration, right? So that's why you will have like some way that it's like flying up, and so then after it reaches V equals to 0, then it drops down again. So it's the same thing over here, which means that there will be a situation that reaches the ground. Okay, then after that, this thing, it stops here. But after that, then what happened here is that it will actually goes up slightly, then until V equals to 0, then it only go back to the direction. Okay, I hope that you get what I mean. So that's why in this question, we need to get what's the length of time, which means what is the t. So you are given the s as well, so we can get the v, so that we can actually find out what do we want as our t here. Okay, so we have u, v, a, s. Yeah, that's good. So we can just continue that. So part C. Okay, so the initial velocity is u, acceleration is given 0.1, s is 0.8 as labeled in the diagram as well. Then we want to find the final velocity, because the final velocity will be the initial velocity for the second stage, which the tension is not longer involved. Okay, so let's try to solve this. V square equal to u square plus 2as. Okay, so v u square 2as, so that would just give us our v is equal to 0.4 meter per second. Okay, so which means what happened now is at this point, v is equal to 0.4. So which means when your particle is here and when it actually move up, maybe it would just be a very slightly movement. Okay, because you can imagine that the acceleration will be a negative one, because it will actually, there's no forces that continuous as well, right? Because so the only two forces that will be exerted is these two force. So that's why when you move to this, then this is your u, right? 0.4. Okay, then we want to find what's the overall t here. So which means that what we get here is we might need to know, we know that the final velocity will be 0, because that's the point that it stops moving, right? Then after that, we need to have what is our new acceleration. Okay, so you can imagine in this point, the motion here is actually not caused by your tension anymore, because that's the point that your string here will become slack, right? So that's the idea. So that's why the only forces that remains in this system is going to be the dm sine theta and also the friction only. So let's try to find the new A. So net force equal to ma. So we have negative 30m sine theta, then minus of the friction, which is the mu r. Okay, then it will be equal to ma. So the m for our question here is 3m, which means for the particle A. Then after that, multiply the A. Okay, so let's substitute all the things that we have. So negative 30m sine theta. So it will actually, we can get it from the 30 sine 30 minus of the mu that we get from the question just now here. So the normal reaction force that we got just now is 15 square root 3m. Okay, then equal to 3ma. So we want to find A, so m, then we don't need to write that anymore. So basically you are just solving what you have here lah. So 30m sine 30, so this is half. So that's why when you multiply, then it will actually give you negative 15m. Okay, minus of this part. So multiply them all together, then you have 9/2. Okay, m. So A is actually equal to negative 6.5. I'm sorry, I still have the 3 here. 3ma. Okay, so I'm just simplify this. So after I get this value, then I divide by 3m, then I'll be able to get negative 6.5 meter per second square. So it's a logical answer for you to get a negative value, because the velocity should be decreasing. So the rate of the change of the velocity should be a negative number, right? Because if not, then how is that going to stop? Okay, so minus, let me check again, 4.5, then divide by 3. Okay, yeah, that's the answer. Okay, so now we need to find the time, right? Yeah, it's not the end yet. So u equal to 0.4, v is 0, new acceleration is negative 6.5, and the question wants us to find out the length of the time. Okay, so v equals to u plus at 0 0.4 plus 6.5 t. So by solving this, then we'll be able to get 4/65, which in 3SF, then it will be 0.0615 seconds. So you can see it's pretty short only. So that's why if we wouldn't able to actually look at it like in a very detailed way, right? So in a real life situation, we might not actually identify the small change in the displacement as well. Yeah, because you can imagine the time is like super short here. So it's like 0.0615 second only. Okay, so which means it will take this time interval to actually for it to stop completely until at rest. Okay, so that's the idea. So yeah, now we'll be looking at the last example. Okay, example 3. So you see this is like a different situation as well. So which means the two of the particle is on this slanted plane. So that's why if there is friction, then it's going to be friction at both sides. Okay, so the diagram shows a triangular block with sloping faces inclined to the horizontal at 45 degree, 30 degree. So the particle A of mass 0.8 kg, so it's here. So we have 8 Newton. Then after that, incline at blah, 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 so 1.2, so this is 12. Okay, so a particle are connected by this light inextensible string passes through the smooth pulley here. So the part AP and BP are parallel to the lines of the greatest slope, so which means they are just parallel to the slope here. So the particle are released from rest, so the U is 0. Both parts of the string is taut. So in the subsequent motion, neither particle reaches the pulley and neither particles reaches the bottom of the face. So which means now we're not sure that how's the pulley is moving, right? It can be to this side, it can be towards that side. But we know that until the end, there's no particle that actually reaches the ground. So this is actually to tell you that for the whole situation, the string is actually taut and these two particles are always connected with this tension. Okay, so that's the idea, because when one already reaches the pulley or one reaches the face, right, then the string here will become slack. So that's why the acceleration will be different as well. So it's important for them to actually tell you this. So that's why when you look at all the questions, they will actually tell you that, I mean, the particle doesn't move the pulley and so on. Okay, so now let's try to look at part one. So given that both faces are smooth, so that's why no friction for now. Find the speed of A after each particle has traveled a distance of 0 0.4. So which means as if our U is 0, our S is 0 0.4, and the question wants us to find out what is our V. So you only left with one variable, so which means you have either A or T. But definitely we can't find the length of the time, right? But we can get A from our net force equals to MA. So that's a thing that we need to do. So that's why for this question, there's no tension involved. So it will be easier for us to use combined system as well. But like what I say, it's the same thing if you are doing separately. Okay, so it's just that when you solve simultaneous, then you are going to eliminate your tension as well. Okay, so now let's try to look at this question. Okay, so you realize that there's one thing that is pretty important in this question is that the question didn't tell you that how this pulley move. And please do not assume that it will always move towards the direction which is heavy, because by looking at this number is the number of, is the force that acting vertically. It's not the force that caused the motion here. So that's why we need to resolve in the direction of the string first. Okay, so we need to compare the magnitude of these two, then we will be able to actually see what is the, or where is the direction of this whole system is pulling. So I'm going to use the purple color here because this is like the resolve. So I'm just going to compare it over here. So you can see when I try to resolve it here, then what do I get for particle A first? Okay, I try to resolve it here. So normal reaction. Let me finish the force diagram. Okay, 45. The normal reaction. A, B. Okay, this two is different, yeah. So same thing, 30. Okay, so when we try to resolve it, then what do we get for particle A is 8, then sine 45. Okay, so for sine 45, when we try to multiply it, and we will be able to get 4 square root 3. Square root 2, okay, which is around 5 point something, I think, because square root 2 is like 1 point something. Then after that for B, yeah, you can just get the value, I guess that's easier. Okay, so it's 5.7. It doesn't need to write in 3SF. This is for our own reference here as only to show you that how do you actually identify which direction the system should be moving towards. So this is sine 30. Okay, so sine 30 is half, so that's why it's 6. So that's why this force is bigger than this force. The whole system will be moved towards this direction. Okay, and that helps you in the combined system later as well. So you can always compare it over here as well. You don't need to write it there actually. So since we are doing combining system, so we just draw it over here. So particle A, so particle B. Okay, so towards this direction, we have the 12 sine 30 just now. Okay, and that's 6. Then after that, for this direction, we have 8 sine 85. Okay, and that gives us like 5.7 something, right? So we write the exact value. Okay, so that's why you can see this number is greater than this number. The whole system is going to move in this direction. So find the speed of the A, so we need to get the acceleration. So the net force is equal to the mass of A plus the mass of B, and then we get the acceleration, right? Okay, so the net force will be 6 minus of 4 square root 2 equal to mass A mass B is 1.2 plus 0.8. Okay, A, then we can solve. So 2A will be just equal to this one. So take the exact value, then you will get 3 minus 2 square root 2. So make sure that for this one, you are writing down this full value. So store this value in your calculator, right? So later when you calculate the answer, then it will be a correct one. So 0.172 when you round it off. Okay, then now we can substitute into the Subat equation. So U is 0, S is 0.4, A is 3 minus 2 square root 2, and to find the V. So UVAS, so V square equal to U square plus 2AS. 0 square 2, 3 minus 2 square root 2S. So let's try to solve it. You'll be able to get 0.1372558 and so. Okay, then square root your answer, then you'll be able to get 0.370. For this question, right, this exact value is super important, yeah, because if you are not using this, you are using this, I guess your last answer will become 0.371. So please make sure that you store your original value and use it in your calculation. Okay, so that's the answer for part 1. Alright, part 2. So it is given instead that the both faces are rough. So the coefficient of friction between each particle and the face of the block is mu. So which means the coefficient of friction is the same since that, the surface is just the same, right? It's the same triangular block. Then after that, the question wants us to find what is the mu when the system is in limiting equilibrium. So now there's no net force already. So which means when you try to resolve it, which means the direction moving towards the particle B and the force moving towards the direction of particle A will be just the same. Okay, so it will be easier for us to find out the normal reaction first since we need mu R in our calculation later. So this is for part 2. Okay, so resolving our A and resolving our B. So let's go back to the question. So yeah, we have this, the resolving the normal reaction here will be 8 cos 45. Here will be 12 cos 30. Okay, so 8 cos 45, and that will give us 4 square root 2. So in this case, then it is 12, then cos 30, right? Then we have 6 square root 3. Okay, remember to write down your exact value, yeah, because you are going to use it in your calculation later. So now, go back to the question again. Okay, so now you see the forces here that after we calculate just now, right, the forces towards this direction is actually more than that. So that's why where is your motion of your friction? Yeah, so remember that your motion is towards that direction, so all your friction should be opposing this motion. So that's why forces B is moving towards this direction, the friction is going here. Okay, then for A is going up, right? It's sliding up, so that's why the friction will be opposing it, which is moving down. So this is very important, yeah. So both of the friction is moving towards the same direction because they are both opposing your motion. It's not opposing your motion. Okay, so now let's try to write it out. What do we have here? So in this direction, we only have the 12 sine 30, I guess. Then it will be equal to the left hand side, which is the friction for B, friction for A, and then 8. So okay, let me try to write it down here. Then I think you can refer to your own diagram, right? Then I can just straight away write it here. Okay, so towards the direction of particle B, then we have 12 sine 30. Okay, and it will be equal to all the three another forces is moving in the opposite direction. So we have friction of A, friction of B, and then also the weight, the resolving weight, so which is the 8 and then sine 45. Okay, so this is the equilibrium. So the forces that going here is the same with the forces going here. Okay, so now let's try to solve it up. Yeah, I'm not writing like this because it's a bit confusing for you guys. Okay, so 12 sine 630, so it's 6. So mu that we want to find, so substitute our R. Okay, and then 8 sine 45 is 4 square root 2. Okay, so sine 45 and cos 45 is basically the same value, so that's why you realize that this value and this value is the same. Okay, so we just substitute, we just find out our mu, right? So factorization, add them up together. Then after that, move this. So 6 minus 4 square root 2 over 4 square root 2 plus 6 square root 3. So from here, then you'll be able to get 0.214. Okay, so which is a logical answer for the coefficient of the friction here. Okay, so that's pretty much of the example here. So you will have two questions that looks like this as well in your exercise. So it's good for you to just practice out how to do the resolving. So basically all the forces that you are looking at is just along the plane. Okay, so yeah, that's the idea of it. If let's say you have any question, just approach me personally. All right, so that's it for today's lesson. Thank you.